Here are our last set of examples on 4.7. We're trying to find dy dx if y equals this. And notice I rewrote this function so that it's obvious I have to use the power and chain rule. So the derivative of y with respect to x is dy dx. Derivative of x squared is 2x. Derivative of y squared is 2y dy dx. And now this one's going to take a little bit of space here. So, power rule, minus 2, that looks terrible. Okay, minus 2 times tangent of xy to the power of 1 times the derivative of tangent of xy, which would be secant squared of xy, times the derivative of the inside, and this we have to use the product rule. So first times the derivative of the second, x dy dx, plus the second times the derivative of the first, which is just y. Alright, we're trying to find dy dx. We have 3 of them. 2 are over here. So we're going to have to get everything with dy dx to one side. Before I can do that, I'm going to have to expand this a little bit. So I get dy dx equals 2x plus 2y dy dx. Alright, now I need to expand this out. I notice I have a 2 and an x. I don't want to forget that x. So I'm just going to bring it to the front. So minus 2x times tangent xy times secant xy, secant squared xy, dy dx. And then I need to expand the other part, so I'll have minus 2 tangent xy secant squared xy times y. And I'm going to put the y in the front again so I don't forget it. Tangent secant squared xy. Okay. So collect anything with a dy dx and put it on the other side. So I have dy dx minus, or actually change the sign there, plus 2x tangent xy secant squared xy dy dx. It looks like I almost forgot one, this here, minus 2y dy dx. And the only things left on this side are a 2x minus this whole part right here, 2y tangent xy and secant squared xy. Alright, because of the way my computer is right now, to save a little bit of time, I'm going to talk myself through some of this. Okay, notice there's a dy dx in each of these 3 terms. So, if I was going to show this step, I would factor out a dy dx. I would have a 1 plus 2x tangent xy secant squared xy minus 2y. Okay, so dy dx times that whole part equals this. And the last step I would do would be to divide by the 1 plus 2x tangent xy secant squared xy minus 2y. Alright, so instead of writing that step, and because I'm running out of space, I'm going to just write the final step right here. 2y tangent xy. We didn't change anything on the right hand side. Okay, and then on the bottom I should have 1 plus 2x tangent xy secant squared xy And last, so that's real y, minus 2y. And there is dy dx. Beautiful looking function. Alright. For our last problem here, there are two parts. However, you need to do the first part in order to do the second part. And so really there's two ways of doing this problem, and the second way you're going to have to do the first way anyway. So I think that it's going to be longer, take up more space, and it's something that you're not really going to do. So I'm going to just focus on the first part, part A. Alright, so we're trying to find the second derivative of our functions. We have to start out finding our first derivative. So we have 6x squared minus 4y dy dx equals 0. Oh, I didn't copy that down right. That should have been a 3, that should have been a 6. Alright, there we go. Don't want to get messed up here. Okay, so solving for dy dx, I have negative 6y dy dx equals negative 6x squared. I just moved the 6x squared to the other side. Okay, you can divide by negative 6y, sorry. So dy dx equals x squared, okay, there we go, over y. So that is the first derivative. Now I'm going to need to take the derivative of this. Right, I'm just going to start that over here. So take the derivative of both sides of this. Alright, equals the derivative of the other side, and it looks like we're going to have to use the quotient rule here. So we have already practiced the quotient rule, product rule, power rule, chain rule, all in these two problems. So the derivative of the first derivative is the second derivative. So d squared y over dx squared equals, alright, the derivative of this function, ho d hi minus hi d ho over ho ho. Alright, so we are almost finished. However, we can't leave this dy dx in our function. We're trying to explicitly solve for the second derivative. So instead of writing dy dx, I can simply plug in what I already know dy dx is. So the second derivative is equal to 2xy minus x squared times x squared over y, which was our dy dx function. And nobody likes complex fractions, so we can multiply the top and the bottom by y. So we get that the second derivative is 2xy squared, because remember I'm multiplying everything by y, x minus x to the fourth all over y cubed. Alright, so this is good enough for this problem. Since today it's kind of a shorter video, I do expect you to do a few problems. Alright, and we'll talk about this in the next class.